Hi everyone, this is Elixir's most published author, Bruce Tate. In this video, we're going to talk about OTP, the soul of Elixir. This video is an introduction to core concepts. If you want to dive deeper, I invite you to come to Groxio. There you will find video courses and professional training opportunities to get that job or secure the promotion that you've been looking for. Let's go! Hey everybody, it's Bruce and the dog on the floor, and today we're working through our OTP video series, and we've landed on our project. We've already started it. We built a dictionary for a game called a word ladder. And the word ladder is pretty simple. We have an answer that we're aiming for. We've given a starting word. Like in this case, we want to get to mice, and we're starting with cats, and we can only change one letter at a time. So for example, we could go from cats to mats to mitts to might to mice. And that's essentially what we're going to build. And we like building things like games because it's a non-trivial problem and it's more than just one operation at a time. And it incorporates some of the techniques that are trickier to get, like the idea of CRC, which is construct, reduce, and convert. And today we're going to be looking at the accumulator for that construct and reduce step. We're going to look at the data model for this particular application that we want to build. It's going to be an exciting episode, so let's get busy. Let's talk a little bit about the work that we've done so far. Right now, all we have is table stakes. So we need some foundations to work on this problem before we can do anything else. And so I chose to do some of the difficult pieces first, like go out and grab a list of words from the internet and cut them up in such a way that we can make use of them. And so here's our list of words. We pulled it from a list, and we've basically trimmed it and sanitized it, removed the profanities and things like that. But that's all we've done here. And then we have this dictionary, which we're going to use to manipulate it. And we broke this out in a separate file from the one that we deal with the words themselves. And the reason that we did that is that we want our overall solution to not have the performance burden of having to load this from a file every time that we need to access the words. So we're going to drop this stuff into a module attribute, and it's going to be computed once when we create the application in the first place. And we also have an index that we build, and let's go ahead and see what that looks like. I'm going to fire off a new terminal. I'm going to start IEX in the context of a project with IEX start mix. And I'm going to say alias ladder dictionary. And I'm going to say dictionary dot words. And I'm going to pipe that into, and I'm going to feed all the words into this API, which is the index words. Okay. And what this gives us is a very interesting and powerful tool for this game, where we could see every word that has the Z in the fourth position, which means that the index is 3. We have a list of all those words, and that's going to let us quickly navigate from one word to another when we're building the new words or when we're checking to see whether an individual word is valid. Okay. So that's the work that we have so far. This really isn't specific to OTP, but it's table stakes. We can't do anything else until we have a good solution for these two problems. Now I want to start to think about how we're going to shape our problem, and we're going to do that next. So here's where we're going next. We're going to look at this module, which we've tentatively called words, but I'm starting to see might not be the best name for this piece of the puzzle. But we have a couple of module attributes in here, and these call the APIs that we used before so that we can cache these so that they're only executed once per execution of this overall program. And that's going to work out in our favor. And then we had a couple of quick APIs which we can now delete that made use of them just so that we could see that they were working. But what we want to do next is determine the data that is going to work with our application. Now, it turns out that when we're working with OTP, it pays to think about this in terms of reducers and reductions. So that means that we need to solve 4 individual problems. The first problem, or the first question, is what is the data type that will go into the Gen server? Let's go ahead and capitalize that. And the second one is, how do I create it? And the third one is, how do I transform it? And the fourth one is, how do I show it to the user? Right? Another way to say this is, how do I consume it? Right? So these 4 questions show up a lot as we're dealing with individual Elixir applications. So much so that this fits a framework for thinking about Gen server design very well. And I'm going to call this CRC. So the first C is going to be construct. How do we create it? The next one is going to be reduce. How do I transform it? And the last one is going to be convert. How do I consume it? These together are CRC, and that's how I think about starting all Gen server projects. I'm going to leave this at the top. So good name for a constructor is new. And probably with this new, we probably don't want to actually build the random words here, because this is our core, and it's best not to have impure things in the core. It's best to have functions that when we call them with one set of properties, and we're always going to get the same thing back. And this property of a system is going to make things easy to test. So I'm going to say my new is going to take a tuple with a initial word and the answer. Okay, and if I have that, I'm going to create something, right? And this is likely going to be some form of a map, because, well, we have different parts of the overall solution. And it's also likely going to be a structured map, meaning that all of the keys, we're going to predefine all the keys that can be in this map. So we'll talk about that in a second. And then this reducer is going to be make a move. And at this point, I need to think about what we're going to call the individual elements. So this could probably be, I probably don't want to call it a game, because I probably want to save the game name for the boundary layer. So let's call this the board. And I'm going to rename this to board. Okay, so this is ladder.board. And so this means I could take a board and a new word. So another way to say make move would be to guess. I think I'm going to use that instead. And this is going to do some work, right? It's going to take the word, add it to the board in some way, and whatever processing that we need to do in this area. And then the last thing that we're going to do is show. We're going to show the board to the user. And so this is going to be some type of a string. And I don't really care what this looks like. Maybe we have some type of a words to that. to that, right? So maybe this is cats to mats to and then maybe here we have like that. And maybe that's the format that we're going to have. But that should be pretty easy to produce once we have the rest of this. But what we need to decide right now is what this initial thing looks like. And we're going to do that next. So let's think about a day in the life of the game. So this is an intermediate game state, and it probably is a good reminder for what we need to track, the data that we need to track. We probably need to keep the running history, and that's going to include the first word, but also the words that we're covering along the way. We probably also need to keep the answer, and that's all that we need to keep. We can calculate everything else that we need. So really, we need the guesses and we need the answer, and that's it. So let's go ahead and build that piece. Okay, what did we say? We needed the def struct, and this is going to be, we're going to need the answer. We could default this to our favorite cats, and we need the guesses, and then we could default that to the empty list, though this isn't what we're going to wind up with. And you know, since these defaults don't really make sense, probably what we want to do instead is just to build the list of attributes, because we're going to build the initial with new based on what these two things are. So let's go ahead and do it this way. Let's say, give me, I want an answer and I want the guesses. Or how about the moves? Because these really aren't guesses if somebody is playing. These are moves. And so this could be take turn. I really don't like the idea that this was guess before, because it's really not taking a guess if it's a skilled player. It's moving towards the solution. So this could be take turn or maybe just a turn. Okay. And so what's this going to be? So the answer is going to be just the answer. And the moves is initially going to be, we're going to have a single one. That's the initial word and nothing else, right? Okay. And so what I'd like to do is, as we advance in this overall program, what I'd like to do is do the validation somewhere else in another layer, because this is where we've already double checked things and we already know that we could apply this word to this board. So the uncertainty is elsewhere. So what we're going to do is we're going to say, we've taken a board. And by the way, this board already has the struct in it. So we don't have to put a module in here, right? In this case, we want to add the word to the words that we already have, right? So we could say, for example, word. We're going to add this to the front of the list because it's almost always more efficient in Elixir to add the words to the front of the list. And so we could say board dot moves. Okay. And so this show can be pretty straightforward too, right? So we have the moves that we know about. We could say board dot moves. And then we can join those together. Let's think about this. So if we're going from cat to mat, or cats to mats, and we're kind of moving on like that. This is the first one, And this is the second one. And if we're trying to build something that looks like this, then we need to flip the board on its head. So let's do this. Let's do an enum.reverse. And then we can join those together with an enum.join. And I don't know that we need the Elixir pipes, but it'd kind of be cool for an Elixir game, right? So we could do that. Though it's not really a pipe at that point, is it? Let's just have a little arrow that joins all of them together. And then, so this is the moves. They look like that. And so the overall answer that we want to return is something that looks like this. I have the moves. Or actually, I could do a concatenation, can I? And I could just concatenate that with, right? So this is going to join all those together. And, right? So that's good. So we're probably going to want to eventually capture a status. But let's see if we can recompile this. Let's see what's it showing me. I have a syntax error on line 16. Yeah, right there. Okay, so board, I see. So we didn't really specify. This is going to be the moves. And then there's a new definition of moves. Okay, so I could do a recompile. So I'll let that fly. Okay, so I still have an error here. So on line 21, this is where we were doing our exploration, so that's okay. Okay, and so I'm going to alias. So now I have a new alias, which is the ladder.board. And I could say board.new. What's my initial tuple? The initial tuple was going what? From cats to mice. Okay, and then we could make a move. We could do board.turn. And then the new word is what? Mice, or no, cats to mats. Okay. And it looks like we're starting to build that list. And let's make another one to board.turn, and let's call this one mitts. And then we could do a board.show. Cats, mats, mitts, and then to question mark. So we have a pretty good start. We have our CRC that's opening up nicely. And you ought to be able to see at this point that we have a couple of flies in the ointment. We can make illegal moves like this, right? So if I'm starting out, I could do board.new, and then I could do a board.turn, and I could go all the way to mice. And our system is going to let us do that fine. We need to do validation at some point, but we want to do this at the appropriate point, and that's going to be at another layer in the system. It's going to be better to do boundary work in the API boundary where it's going to cause us less heartburn. So I'm going to process things like user input, uncertainty, process machinery, external APIs, all that should live in a boundary layer. And then it's going to give us the advantage in the boundary with being able to compose with more sophisticated machinery, which is going to be more difficult to use. So I have to use simpler machinery in the core, but it's going to make the compositions more beautiful, which is going to improve my ability to test and execute the code and do things like that. When we meet next time, we're going to move ourselves from the boundary to the core to the test layer of the system. And I want to show you a couple of tricks that we can do as we're doing some integrated tests that actually work on the core. But right now, we have everything that we need to plug into a working OTP system, and that's an excellent thing. From Bruce and the dog on the floor, this is Groxio Learning.